In our last video, we saw how we can blink an LED using Arduino and understand how the program works in its linear fashion. So in this video, we are going to explain everything in detail, down to every single line and symbols. And we will also going to increase our programming skills by going through important concepts such as functions, arguments as well as data types. This is going to be a really detailed video, but don't worry, we will try to explain things in a really simple way. Even if you don't know C or C++, or just skipped classes, or don't even have any prior experience in programming, this video is for you. By the end of this single video, you will be able to visualize the working of functions, arguments as well as data types. If we recall, after opening a new sketch, few lines of code were already present. So let's cover those first. If we take a look, we will find two functions, that is setup and loop function. If you don't know what functions are, then just keep watching and it will be all clear. Function is a reusable block of code that performs a specific task and can be called multiple times again and again in a program. To understand it much better, let's take the help of the function loop. So as we remember from our previous example, the LED glows for a second, then stays off for another second. Even though we wrote the code only a single time, but the LED keeps blinking. So why is that? It's all because of loop function. It reuses the block of code inside these brackets again and again in this program. As a result, the LED keep on blinking. Now what is setup function and why we use it? As the name says, it's also a function, but instead of running again and again like loop, it only runs once when a sketch or a program starts running, or we can say when the Arduino boots up or when the reset button gets pressed. Its purpose is to initialize the variables, pin modes and other necessary configurations for the sketch to run correctly. In simple terms, it's used to define those pins or variables which does not need to be changed every single time after the program starts, or we can say those pins and values that need to stay same for the entire program are used inside setup function. In our LED blink project, we always want pin 13 to act as an output for the LED. So pin mode 13 output is inside setup function. Or we can also say, if we are making an actual circuit, then it doesn't make sense to first make pin 13 to act as an output for the LED. Then let's say pin 8 to be an output to glow that same LED. So that's why we usually put pin mode or define pin mode inside setup function. But for some reason, if we decide to put pin mode inside loop function, it won't going to give us any error and it will still run, but it won't be efficient because the program inside loop function executes and run again and again and again. So if we put pin mode inside loop function, the microcontroller has to run pin mode every time the loop ends, which leads to an unnecessary work for the microcontroller. So that's the another reason why we are putting pin mode in setup function. Then there is brackets or parentheses after every function. We need to put these brackets after calling or using every function because Arduino IDE is based on C and C++ programming. And in C and C++ programming, we always have to put parentheses or brackets after calling any function. If we see in loop and setup function, the brackets are empty, or we can say without any arguments or values. On the other hand, functions like pin mode, digital write, delay, all have some values inside brackets that has to be passed into these functions so that they can work correctly. Let's say if we don't pass 13 output in pin mode, the compiler won't be able to understand which pin we are talking about and whether it's an input or an output, and it will give us an error. In the same way, if we don't pass 1000 in delay function, the compiler could only be able to understand that it has to wait, but could not know for how long it should wait before moving to the next line, and again give us an error. Now a question for you. What would happen if you don't pass any arguments with the function digital write? If we don't pass 13 high or low in digital write, compiler won't be able to tell which pin we are talking about, or whether to increase its voltage or decrease it. So in summary, Functions like loop and setup don't need any kind of values or argument to work correctly. But every other functions needs these arguments so that they can perform their operation. Now let's talk a bit about semicolon. Semicolon is known as a terminating character, and it tells the compiler to differentiate each line of code, or we can say statement in our program. It's because the compiler isn't very smart and it cannot differentiate between two lines of statements. For example, digital write 13 high is one statement and delay 1000 is another statement. If we don't use semicolons, the compiler will going to get confused and give us a syntax error. So in every programming language, we need to put semicolons at the end of every statement. If we look our code carefully, we will notice we don't use semicolons after void setup and void loop, but we just learned we need to provide semicolons after every statement or after every new line of code. So why semicolon is not present here? Well, we can also add semicolons after void setup and void loop, and it will still going to be correct and will not going to give any error. But it's kind of unnecessary to put semicolons after setup and loop function, because setup and loop functions are not standalone functions. They just control the flow of the program. They aren't telling microcontroller to perform any task, but just control the flow. We will see many examples on this in further videos, and those things will get more clear as we practice more. Are we forgetting something? Oh, void. So what is void? Well, void is data type. So what is data type? We will explain all things about data type in some other session, so this video won't get too long. Basically, if we add two numbers, for example two integers like 1 and 2, we expect our answer would also be an integer. That is 3 in our case. But let's assume we ask the same question to an over smart kid to add 1 and 2. He don't know if it's just 1 or 1.00, also 2 or 2.00. So he might take our question as 1.00 plus 2.00 is equals to 3.00. If you are thinking what's the big deal, as 3.00 and 3 is same value, right? Well, yes, 3 and 3.00 both hold a same value. But if we talk about computers, every digit takes memory. So 3.00 will take more memory as compared to 3. So we have to tell our computer or microcontroller that both 1 and 2 are integer numbers, and he should expect integer number as a result. So it's all good. We have to tell our dumb computer if the number is integer or a decimal. So what it has to do with void? Void means nothing. Seriously, nothing. No values. So the point is, when we call a function, we also need to tell the computer which kind of data it should expect as an output. But it's not always the case for some functions. We will go there in a bit. But for setup and loop function, they won't actually perform any operation in our program, but just control the flow of our code. That's why they won't return any values to make any kind of calculation. So that's the reason we use void as a data type. This makes our compiler clear that setup and loop functions is not expected to return any value. So the microcontroller is not going to allocate any memory to store this value. But wait, just a minute ago I said not all functions have to be used with data types. Well, for some functions, Arduino IDE can automatically assume their data types and automatically put them for you. For example, in digital write high and low, here compiler can automatically assume the value of high as 1 and low as 0. So it automatically put the data type as Boolean data type, that is 1 and 0. Don't get too confused with data types. We will discuss every kind of data type in future videos. So what about delay 1000? Here again the compiler can assume the data type 4000 by itself, that is unsigned integer. Don't worry if you don't fully grab all details about data types in this video. It will get clear as we go along. Let's end this video by explaining comments. In programming, comments are lines of text that are added between the code to provide information and explanation to human reader. Comments are not executed as a part of program and are typically ignored by the compiler. In Arduino, there are two types of comments: single line comment and multi-line comment. To use single line comments, we just need to type 2/. To use multi-line comments, we need to type / with star, and to end this, just type star with /.